Hello. This presentation and associated paper is titled Recorded Energy Consumption of nZEB Dwellings and Corresponding Interior Temperatures. This work outlines initial results of the nZEB 101 project being run out of University College Dublin in Ireland, and it's funded by the Sustainable Energy Authority of Ireland. I am Oliver Kinnane. I'm a lecturer at University College Dublin, and I'm presenting this work on behalf of the lead author, Shane Coakley. I'm a co-author, and the others include Richard O'Hegarty, Donal Lennon, Etienne Rioux, and Philip Griffiths. And today we're presenting on a collection of the many buildings that we're analysing as part of the nZEB 101 project. This in itself is just a collection of the buildings that are reported on within the paper. In total, we report on 17 dwellings, and our ambition is to monitor over 101 nZEB dwellings through the course of the project. The selection of dwellings in this paper includes a wide range of building typologies: semi-detached, detached, bungalow, two-storey, terraced housing. It includes new housing built to the nZEB standard and housing that has been retrofit to the nZEB standard. It includes timber frame and concrete blockwork buildings. Data is recorded on the overall energy consumption and the heating energy consumption for all dwellings for a period of at least 1 year. In addition, there is 5-minute data on the indoor environmental quality parameters of air temperature, relative humidity, and carbon dioxide. Just as an example of the type of housing that we're analysing, here I show houses that were retrofit through the Deep Energy Retrofit Scheme. This scheme of houses shown here comprises 12 one-bedroom, 30 metre squared social housing dwellings located in Wexford Town in Ireland. They underwent deep energy retrofit in 2018. The houses were originally built in 1970. Prior to the upgrade, the dwellings had issues with inadequate ventilation and thermal bridging, resulting in damp patches and mould on the interior surfaces. The dwellings range from the second poorest building energy rating, that's the BER categorization of buildings, which I'll refer to through this presentation. So they range from the second poorest F, which had a regulated load of over 400 kilowatt hours per metre squared per year, to the worst, which is category G, with an energy rating of over 1,000 kilowatt hours per metre squared per year. The building regulations in Ireland state that for a retrofit, houses must reach an energy performance of at least 125 kilowatt hours per metre squared per year, which is a B2 or better in the BER categorization. Following retrofit, all these houses are shown to be designed to an A standard, most within the A2 rating, which is 25 to 50 kilowatt hours per metre squared per year. One of the primary aims of the nZEB 101 project is to compare the nZEB buildings as designed and their predicted energy performance with the energy performance of those same buildings in operation. And here we see columns that list the building, the predicted performance of the buildings, and then the actual regulated load of the buildings. The buildings in this table, the buildings which exceed the expected energy consumption BER rating, are highlighted in orange, and those which operate within or below the expected energy consumption are highlighted in green. So you can see that the recorded performance does not match the predicted specific regulated load for the majority of the dwellings. That's 8 out of 12 of the dwellings. For nZEB 1, 7 and 8, all these dwellings are on the same site. They were constructed at the Passive House standard, with all having identical construction and heating systems. And all 3 dwellings exceed the predicted regulated load by approximately twice. Similarly, in the case of the retrofit nZEB dwellings, 23, 25, 26 and 27 shown, all exceed the BER expected energy consumption, typically by a factor in excess of 3. Also, it's worth noting the average dwelling temperatures. The dwelling energy assessment procedure, that's the DEEP software that we use to analyze the buildings as designed, states an indoor set point temperature of 21 degrees for the living room and 18 degrees for the bedroom. So we use box plots to compare the temperatures in the different houses for different times of the day through in the winter time. And here we show such a box plot, which shows the temperatures in the different houses versus the average temperature throughout. So these box plots show the temperatures for the living room, and they indicate the median living room interior temperature are higher than those expected by the energy rating software, and considerably so in certain situations. Similarly, when we look in the bedroom, we see temperatures much higher than the 18 degrees as predicted by the software, even some up to 24.5 and over in certain cases. So this research is very much still in development. The project is at its early stages, but some of the discussion points are listed here, and primarily that the majority of the buildings are consuming more energy than predicted by the DEEP software, and that the internal temperatures are significantly higher than the DEEP software. So I would recommend that you review the paper, and I hope you'll find it interesting, and thank you for your time.